Hello, everyone. You're in the right place. We will be shortly starting. We're just waiting for everybody to join. Uh, mhm. Hello, everyone. You are in the right place. This is Hedera's webinar. We will be starting shortly. We just want to let people join. Hello. Yes, Piotr, I will explain that in a second. We will be this call is being recorded. This webinar is being recorded, and it will be placed on our website and YouTube channel. So, also welcome. You have a very nice background, Donald, as well. A good one.
I'll thank our marketing team for that.
Okay, well, I think we can start, and we'll see how many people join us as we go. Welcome, everyone. This is Marta Gider-Pikarska, and today we will be listening to a webinar and watching a webinar from Donald, who works with Hedera, and Donald will be telling us about a public decentralized ordering service for Hyperledger Fabric using Hedera Hashgraph. A few housekeeping rules before we start. This meeting, as all Linux Foundation meetings, is held under the antitrust policy. If you want to read the whole policy, please use the QR code below so that you can read the full document. Basically, please make sure that you do not share any intellectual property that is not your own if you do not want it to be public. This video is being recorded, and we will be making the session available through our YouTube channel as well as on our website. So hang in tight. And finally, we will be releasing the slides as well. Donald was kind enough to share them with me, so we will be adding them to the recording. If you would like to ask a question, please use the Q&A box in your bar. If you want to chat to other participants or the whole group, you can use the chat. If you want us to pay attention to you, you can raise your hand, but please make sure to use the Q&A for questions. It was just easier for us to track this. So with that, Donald, over to you.
Fantastic. Do you mind if I steal the screen share?
Go for it.
Great. And just confirming you can see my slides all right here.
Yes, we can see your slides and we can hear you well.
Fantastic. Well, good morning, good afternoon, everybody. My name is Donald Thibault. I'm the Director of Product with a company called Hedera Hashgraph. We joined Hyperledger last year and have primarily focused on sharing how the Hedera consensus service, one of the services provided by our public mainnet, can be used in conjunction with permission frameworks like Hyperledger Fabric. So today I'm going to share a little bit about that integration, as well as a demo that we built showing how a Fabric network can leverage the Hedera consensus service for transaction ordering, and discuss many of the benefits that we and some of our partners have been seeing through integration of Hedera consensus service for ordering. So with that, I'll jump right in with a bit of background on Hedera. So when I tell people about Hedera, I really define two components. The first is our Hedera Governing Council. So Hedera Hashgraph as a company is actually a multi-member LLC. That means that the companies who are members of our council, those logos you see here on the screen, like Boeing, IBM, Google, LG, DLA Piper, and more, actually sign on as members of our LLC and serve as that role for 2 consecutive terms of 3 years each. So these companies are actually our owners in a sense. So not only do they serve in a governance function to help us make technical and strategic decisions on everything from our product roadmap to our go-to-market. But they also operate the nodes of the Hedera mainnet. And that's the second component I'll define, the Hedera mainnet. So the council members each operate a node in an on-premise or cloud data center of their choice, spread across the globe. So our network is actually fully decentralized from a governance perspective, seeking multiple organizations from different industries and different geographies, as well as from an operational perspective. No nodes are co-located in the same data center, and it's truly multi-cloud and distributed across a different set of environments. Now, those nodes use something called the Hashgraph consensus algorithm to provide a fast, fair, and secure ordering of transactions in the network. Hashgraph combines two innovations. First is gossip about gossip, and the second is virtual voting to deliver consensus on the scale of tens of thousands of transactions per second with finality in a matter of seconds. So the Hashgraph consensus algorithm first uses gossip about gossip. What that means is that not only do nodes share the latest transaction or event which they heard, but they share the full history of events which they've heard in the past. So they're not only gossiping those events, but they're gossiping about all of the gossip that they've heard previously in a given round. What that means is that the nodes on the network come to consensus on the full view of events that have been submitted far faster than any other consensus algorithm. And that enables the second core innovation, virtual voting. If you know what I know, and I know what you know, because we've gossiped not only about the event, but the gossip about the gossip, then we can more efficiently come to consensus on our timestamp or consensus timestamp for each of an individual event. So ultimately, both of those innovations serve to allow nodes to determine a median timestamp for each individual event without compromising on centralization. Each node participates in every round of consensus. Unlike other models like Raft or other proof of stake models, there is no concept of a leader. There's no risk of an individual party, either maliciously or accidentally, bringing down the network. And collusion is difficult because it is fully decentralized for consensus in every round. Now, on top of this Hashgraph consensus algorithm, we've built a set of network services which make the benefits of decentralization easily accessible to developers. The two that are relevant for today's webinar are our cryptocurrency service and our consensus service. Each of these services can be thought of as a set of APIs, which can integrate with any third-party application, i.e. as a public network, to support use cases from real estate, trading and securitization to tracking of supply chains for healthcare, as well as what we'll talk about today, to transaction ordering for private distributed ledger technologies. Our cryptocurrency service allows accounts to transfer HBAR, our network token, between themselves in a peer-to-peer manner, and currently supports around 10,000 transactions per second with finality in a matter of seconds. And our consensus service allows any application to submit a transaction to the Hedera mainnet in order to get a transaction timestamp or consensus timestamp of that message. And we'll talk today about how that can be used in the context of a Fabric network. So just a note on the adoption that Hedera has seen to date. So we became publicly accessible in September of last year. So we're less than a year of open access. And since then, we've supported nearly 250 million transactions and almost 45,000 accounts on the mainnet. Now, what's unique about this level of activity is it's not driven just by exchange or transfers of cryptocurrency like other public networks, but driven by real enterprise and consumer applications. So for instance, AdsDAX, one of the largest users of our network, has built an advertising provenance platform that logs events, i.e. impressions of an advertisement to a consumer, using the Hedera consensus service. In doing so, they generate a cryptographically verifiable proof of each ad impression, which can then be used to cut down on dispute resolution, auditing, and fraud in the digital advertising space. They alone have tested thousands of transactions per second from their application and continue to drive a large amount of the workload on the Hedera mainnet. To share a bit more about some of the use cases we've seen in addition to ad stacks, I'll mention a few specifically that have been led by different members of our council, community members, or independent organizations. A number of organizations are exploring central bank digital currencies, which allow permission frameworks like those built, or networks like those built by Hyperledger Fabric, to use the Hedera consensus service as a global ordering service for those networks. And we'll talk more about that model later. We've seen organizations explore stablecoin issuance so that they can have frictionless peer-to-peer payments with a stable market value. A number of organizations have explored digital identity for recording verifiable credentials using the Hedera consensus service. We built a Hedera DID SDK, for instance, which uses the W3C DID method and in conjunction with the Hedera consensus service to support verifiable credentials use cases. We've also seen many organizations who use the Hedera consensus service for establishing proofs of compliance for regulatory events. So just the other week, we did a webinar with a company called Manitou to showcase how they're leveraging that in production. There's also organizations like AdStacks who are using Hedera for auditable logs to generate those cryptographically verifiable proofs of application events to ensure that their application, whether it's centralized or decentralized, has auditable events that can be shared with any third parties. We've seen a number of organizations explore integrations of those logging into enterprise systems, typical ERPs and other message queue tools. And of course, we've also seen interest in network interoperability. One of the benefits we'll talk about today of using the Hedera consensus service is a globally shared ordering of transactions can make things like atomic swaps and communications between permission networks far easier. Now, I don't just mention these as words on a slide. In the slides, you'll see that each one actually links out to specific demo code that our team has built, showcasing how these use cases can be built on Hedera. Many of them include programming models like Hyperledger Fabric for demonstrating that use case. So I encourage you to check that out and let us know if there's one that's particularly interesting to you. So now with that out of the way, I'll dive in to what we've built in our Hyperledger lab, making the Hedera consensus service accessible for a Hyperledger Fabric network. So as I mentioned earlier, the Hedera consensus service provides an auditable log of transactions for any network or application. Permission networks, which are great at providing the privacy, customization, data encryption, and identity management that a business network needs, can now leverage a highly available permissioned public network for transaction ordering, i.e. the Hedera consensus service. So in this model, we see a combination of the best of both worlds, of the permission frameworks with public networks. So we see the permission networks provide that custom data access and encryption, while Hedera provides a public trust model for ordering of transactions in those networks. We currently support this integration with Hyperledger Fabric, consistent and tested up through Fabric 2.2, as well as other permission frameworks like R3's Corda. And our aim is to support not only these individual networks being built by enterprises leveraging the Hedera consensus service, but also supporting communications between these distinct networks when appropriate. So To share what you'll see in the demo before we dive into some of the technical details, we'll see a fabric network, in this case, built using the FabCar sample chain code that's customized for the purposes of tracking a car supply chain. That fabric network uses a set of peers who operate a shared piece of chain code that encapsulates the business logic of the use case. The chain code leverages endorsement policies to first endorse transactions according to that chain code, and then submits those endorsed transactions to the Hedera consensus service for transaction ordering. That consensus event is then returned back to each of the organizations in the Fabric network independently for them to batch the ordered transaction into a block and update their respective peers. And the benefit we see is the ability to have a customized Fabric network receive an auditable and fully decentralized order of transactions, which they then use to update their private blockchain or their peers. Each organization can independently send and receive transactions from Hedera, which means that there's no need to rely on some third party to provide a relay for transaction order, and thus also giving them a highly available, globally distributed orderer out of the box versus needing to build and customize one themselves. So I'll jump now over to the video. So at the right, you'll see the FabCar demo application. We leveraged an open source community UI to build this demo, so we're very thankful that that code was available as well. At the left, you'll see the user interface for a company called Kabuto. Kabuto provides a blockchain explorer for the Hedera mainnet and public testnet. So you'll see the interactions in our Fabric network at the right being connected to messages sent to the Hedera public testnet for consensus. And you'll see how those messages are represented in this demo. So first, we'll go through the process of querying all cars in the specific Fabric peer. Because this interaction is just local to a specific peer, i.e. the application asking for information from the blockchain, there's no related Hedera message. Now we'll go through the process of actually transferring a car, which will require invoking chain code, and we'll see a Hedera consensus service message ordering that transaction. So we'll enter the car ID and the new owner, and then trigger this transaction, which will start first for request to transfer requiring the endorsement. Once endorsement's collected, that's been sent to the Hedera mainnet. You can see that here is message 77. And that means that the message has come to consensus on its timestamp or the order in a matter of seconds and with finality. So there's no risk that the actual message changes order because the Hashgraph consensus algorithm provides that asynchronous Byzantine fault tolerant and final order. If we now go and look at the new car ID, we can see that it exists on the peer and it's been fed based on those ordered messages from the Hedera consensus service. We can also create a new car, which similarly invokes functions from chain code. And we'll then go through the same process of collecting endorsements, ordering by the Hedera consensus service, and returning to the Fabric organization for them to update their respective peer. Now, in this demo, we leverage the full Fabric transaction itself being sent to the Hedera consensus service. So it would be sent as a series of messages which are ordered. But in our plugin, we enable encryption to be optionally used for those use cases where public visibility of the actual transaction data is not allowed. So depending on the use case, you can either have public or encrypted data leveraged for the actual Hedera consensus service message. So this demo, along with our actual Build Your First Network demo, are both available in the Hyperledger GitHub under our Hyperledger Lab pluggable Hedera Consensus Service, and also available at docs.hedera.com, where we provide a helpful walkthrough of that code and how you can get it up and running yourself. So now that we've seen the demo from a UI perspective, I want to talk a little bit more about what happened on the back end. And what's critical for understanding this application is this model we have here. Again, the Fabric network being used for storing the blockchain, running chain code, and endorsing transactions, and the Hedera network, which provides transaction ordering for the updates to the Fabric peers. So let's break down each side of this graph. First, we have the Hedera mainnet. These are the nodes operated by the Hedera Governing Council, which use the Hashgraph consensus algorithm to determine a unique and final timestamp for each message sent to Hedera. I mentioned in the demo, but this is the only asynchronous Byzantine fault-tolerant consensus algorithm, which is the gold standard of distributed computing in that it provides a fast and final timestamp without electing a leader or compromising the decentralization of the network as a whole. Now, once these nodes determine the consensus timestamp of a message, they share that result with something called a Hedera mirror node, or a mirror node operated by a third party. So in our demo, we saw the Kabuto mirror node. These mirror nodes all receive those records from the mainnet itself and can provide long-term data storage either for the network as a whole, if they're providing a mirror node as a service, or for a specific application. So you could have a mirror node which stores only the information relevant to your Fabric network. Now, the final component is the actual Hedera consensus service. So we use the term of message submission to denote what is sent to Hedera from the Fabric network. There is a message which can be defined by the application to be anything from a hash or some other string of data. In this case, it was actually the details of a Fabric transaction. The message will specify a topic ID, which is a unique ID for the application or Fabric network, and can be permissioned so that only specific parties can submit to this topic ID. And the Hedera and the submitting account, which pays the 1/100th of a penny transaction fee for use of the Hedera consensus service. This is also a benefit we see from a cost perspective because networks only use what they use in terms of TPS for ordering transactions versus needing to pay for a robust ordering service that's operational even when it's not used. Now, in return, the Hedera mainnet, again, will determine that consensus timestamp of the message. This timestamp is what's used to order transactions or messages with respect to one another from a common topic ID. So message A will get a timestamp and message B will get a timestamp, both for a specific topic, meaning that any peer or organization can independently verify that transaction order for the Fabric network. The network also provides a sequence number with respect to the other messages in the topic ID, and a running hash, which is also calculated for the messages of a common topic. And it's these three primitives which can then be used by a Fabric node or organization to structure the messages into a block, which is then appended to each of the peers' ledger. So let's look specifically at how this Hedera consensus service is used in the context of a Hyperledger Fabric transaction. So at the left here, we have the Hyperledger Fabric code. The transaction is proposed first to a Fabric peer. This is when the transaction collects the endorsements as per the endorsement policy currently enabled by Fabric. And once that has been endorsed, the client application then broadcasts this transaction to the organization's orderer. It's at this time, post-endorsement, that the Fabric orderer leverages our plugin to submit that transaction for ordering to the Hedera mainnet. The transaction would be either put into a single message if encrypted, or a series of messages if not, and is submitted to Hedera with the associated topic ID that was configured for the Fabric network, i.e. the ID number of this Fabric network. The Hedera mainnet would then come to consensus, as we mentioned, on the timestamp of that message, and provide that output of consensus timestamp, running hash, as well as sequence number to any of the Hedera mirror nodes. The mirror nodes would then automatically stream this information back to each organization in the Fabric network, which is then used by each organization to reassemble an ordered transaction into a block, which is then appended to each individual peer. So what we see again is the endorsement and data for a specific business process remaining in the Fabric network, while the ordering is provided by a globally decentralized and resilient public permissioned network. To share a bit about what we've actually built on the back end, we support many of the basic Fabric features and functions with the plugin. So for instance, we support the concept of block cutting and management for updating the peer. We support channel management so that each channel can maintain its own topic ID to ensure separation of transaction ordering at a channel level. We also enable configuration transactions, which are used to deploy chain code or actually set up the Fabric network itself. And we also make encryption optionally available for the Fabric network to use if it so chooses. We've had a pretty easy job of building that plugin because there's a number of Hedera SDKs in Java, Node.js, and Golang, which support all of these functions. But certainly with the plugin, we enable that interoperability directly with Fabric networks. So I'll mention a few of the other changes that you'll see if you go to our Hyperledger Lab repo. As mentioned, you can see the channel-related common configuration changes. So we have essentially a new consensus type that's added to support the Hedera consensus service. We've added some other per orderer configurations. So different configuration items needed to manage keys for interacting with the Hedera network. We've again added that new consensus type, mapped those channel IDs to the topic in the config.tx file. And again, also made updates to the orderer so that it develops or has the Hedera account necessary to submit a message to the Hedera mainnet. We also allow the ability to subscribe to any different mirror node. So there's full decentralization all the way down to the Hedera mainnet for any Fabric application. So lastly, I'll just mention where you can try this out yourself. Certainly we have the repository for our Hyperledger Lab pluggable HDS in Hyperledger. And we also provide instructions at our docs.hedera.com website for standing up your Fabric network. We've seen a few partners and clients who've started with private and centralized Fabric networks stand up their own network connected to the Hedera consensus service. So organizations like Hala Systems, who is building a data authenticity use case, as well as many others who are taking their Fabric networks to the next level of decentralization through use of the Hedera consensus service. So with that, I'll jump over and see if there's any questions in the Q&A, and happy to answer any others that may come up as well.
Wonderful. Thank you, Donald. That was very interesting. Let me just quickly check the chat and the Q&A. I don't see any questions from Oh, here we go. What is the advantage of using HCS? I think there's some issues like network bandwidth, network latency between order and HCS.
Certainly. So at the top level, the benefit of HCS is decentralization. So rather than needing to figure out how to deploy a set of orderers communicating with one another between different data centers, geographies, and organizations, a Fabric network builder can essentially get access to that globally decentralized ordering service out of the box. So both from a governance perspective to actually set up the network and to operate it long-term, it's easier to use essentially a simple set of APIs versus needing to develop something custom for a specific Fabric network. We also have seen a performance benefit in terms of TPS. We leverage specifically Hyperledger Caliper to do some basic benchmarking. There is, of course, a change in latency, as mentioned, when you use a public network instead of something more centralized. But we generally see finality for individual messages in about 2 to 3 seconds. So that is definitely a consideration for the use case, but something that we've seen as able to overcome for Fabric networks. I also see that there's a question here about which versions before 2.2 it's applicable. When we submitted the lab, it was compatible with Fabric 2.0. And we have also integrated the Hedera-based orderer with version 1.6 network as well. But 2.0 and 2.2 is what it supports out of the box. There's just some additional configuration changes that might be needed to make it backwards compatible for 1.6. The other, maybe just last benefit I'll mention of HCS, when we talk about growth of Fabric networks, typically we see a lot of networks begin in more centralized proof of concepts where a single organization is using it to track data through their supply chain. Maybe they're bringing on a few partners. But what we know about Fabric networks and business transactions in production is that you need to have that connectivity be easy between different networks. So for instance, a payments network that can integrate with a specific supply chain. Our view at Hedera, and one we've seen interest in from a number of organizations, is that when disparate networks are built with a common ordering service, it's far easier to enable connections between those networks because they can reference a single source of proof and timestamp for their different business events. So say you need to support atomic swaps or sharing of data, we see the Hedera consensus service as a great way to do that in a decentralized yet enterprise-ready way.
Great, thank you. There's Sam Gamble is asking, what is the economic model for using the ordering service and who pays what and when?
So Hedera, although it's an LLC, really operates as a nonprofit. So our objective is to build and operate this shared public utility. What that means is each of the services are provided essentially at cost for use without restriction by any public user or developer. So specifically for the Hedera consensus service, each message has a fee defined and fixed in US dollars that is required to be paid in HBAR for using the consensus service. That's around 1/100th of a penny for a specific consensus service message. And that's guaranteed to be stable over time so that it doesn't fluctuate like we see on other public networks based on things like gas price. So a Fabric network would only pay for what they use in terms of the number of transactions ordered, and they would be able to easily predict how those transaction fees will grow over time based on utilization because it's fixed and stable pricing. There's also, again, that governance role that the council provides, where they make pricing decisions about the network in line with the needs of these types of enterprise networks. So we get a high degree of stability for our users. Finally, we also have this concept in Hedera of no forking. So other networks which are operated by anonymous node miners or pools have a risk of forking when they do things like upgrade software. Because our nodes are only operated today by the Hedera Governing Council, and because the Governing Council agrees and determines which software is used on the nodes, there's a guarantee that the network itself will not fork over time. So what you wouldn't want to happen is to wake up one day and all of a sudden there's 2 versions of your ordering. Hedera ensures that it will prevent forking, therefore providing stability for the users of the network as well.
Sorry, I was muted. Then there's a question of, is it possible to make a private deployment of Hashgraph without using existing mainnet and having a private network?
There is not currently an option for private deployment of Hashgraph. If you have a use case where you think that might be necessary, I'd love to chat more and learn about that. But currently, the Hedera public mainnet is the available option for Hashgraph consensus.
Right. And what are the challenges while integrating the Hyperledger Fabric APIs on mobile platforms? Did Hedera integrate with mobile platform? Is Hedera integrated with mobile platforms currently?
So the great thing about our integration with Hyperledger Fabric is it doesn't actually change much about the Fabric programming model itself. So any integration you have from a front-end application to a Fabric network wouldn't really need to change because it's only the orderer that's communicating with a Hedera consensus service. So in terms of mobile development for Fabric, that can continue as is. Now, in terms of using the Hedera services itself, we have a set of SDKs like in Java, Node.js, Golang, as well as some developed by our community, which make it accessible for a wide range of programming models. We have also explored specifically mobile systems like React Native, which is possible. We do have a number of mobile applications leveraging Hedera. So that is something we've seen used before as well.
Great, thank you. So I don't see any more open questions. I would want to ask you, how was your experience with kind of bringing the code on board to the labs? How did you even do it? I'm sure that many people here don't even know how does one, can anybody bring code to Hyperledger, or is there some kind of a requirement?
Yeah, so I'll share a bit about our experience. So we got a tremendous amount of support from the Fabric maintainers community, who helped us validate the design of the actual consensus service plugin. So we talked in both Fabric maintainers calls as well as with some of the maintainers themselves to help design our plugin, which we then used to actually create the pluggable consensus lab, which we submitted to Hyperledger. From our perspective, it was a seamless process in terms of creating, submitting, and getting that lab approved. The technical steering committee all was active in giving us feedback and requests on everything from the format of the document to the code itself, which we found particularly helpful in getting through the lab creation process. Now, we're really interested in building the community using this plugin. So if there's a use case that you have that could be relevant for this plugin, certainly engage with us in GitHub, but also feel free to reach out to myself directly. My email is in the slide, and we'd love to talk more. We also, I'll lastly mention, got a lot of interest and help from sharing this and discussing this at the Hyperledger Global Forum. I've colloquially called it the last business conference ever, given its timing, but certainly we saw a great amount of engagement from the community when sharing our lab in that process.
Great, thank you. Let's check if we have any open questions. I don't see any. I think that you did exhaust the topic, I guess. Thank you very, very much for being part of this program. Just to wrap up, I would like to let you all know that this is a series. In case this is the first time you're joining us, this is a series of member webinars. The next two ones that are coming up is one from a company called Clear on creating an API first settlement solution. This will be around telecom industry. Should be quite interesting. They've been working with very big companies like Telefonica, Deutsche Telekom on creating this one settlement scheme. So for those who are passionate about telecom or want to learn more, I would welcome you to join us. And then we will also be having a Hyperledger Umbra webinar. This is Hyperledger Umbra is another lab like the one that has been presented right now. This one is focused on challenges with Hyperledger Fabric simulation and debugging of applications. It's aimed to help students and researchers understand how to work with Hyperledger Fabric. And all of the events are always listed on our hyperledger.org/events website. As Donald mentioned, we did have Hyperledger Global Forum in March. It was my last business conference as well. And we did record all the content. So in case you are hungry for more content, go to our YouTube channel and not only rewatch this presentation that will be placed there, but also you can watch hundreds of sessions and various presentations that we've done throughout the time. And please get involved. We welcome you all to this community. We are very open. We are very inclusive. If you want to learn more, email us. If you would like to jump straight into the code, then feel free to download the code. And I hope to see you next time. Stay safe.
Thank you.